Now we can talk about QC questions and integer properties. And of course, the GRE loves to ask about integer properties. In this lesson, I will assume that you are familiar with all the properties discussed in the integer property module, that you're familiar with all of that. Integer properties includes odds and evens, divisibilities, factors, greatest common factor, least common multiple, primes and prime factorizations, consecutive integers, and division, and quotients and remainders. Remember the important exceptions. All prime numbers are odd except for 2. And 2 is the only even prime number. It's also the smallest prime number. All numbers are positive or negative except for 0, which is neither positive or negative. The only number on the infinity of the number line that is neither positive nor negative. All positive integers are either prime or a product of prime except for 1. 1 is not a prime number, and 1 is not divisible by any prime numbers. 1 is a factor of every positive integer, and every positive integer is a factor of itself. Any of these could be good fodder for a GRE quant comparison question. Something may seem true if you forget an important exception. Recall that when a number, a dividend n, is divided by a divisor d, this produces a quotient q and a remainder r. All this was discussed in the remainders video, and I'll just give a brief review here. For example, when n equals 17, when the dividend 17 is divided by the divisor 5, 5 goes into 17 3 times, so the quotient is 3 with a remainder of 2. Recall that the remainder is always less than the divisor. Recall also that if the divisor is greater than the dividend, then the quotient is 0 and the dividend equals the remainder. For example, suppose we divide 5 by 137. Well, 137 goes into 5 0 times with 5 left over. So 5 is both the dividend and the remainder, and the quotient is 0. Finally, recall the rebuilding the dividend formula. That's how all 4 of these quantities fit together. And again, all this was discussed in the video on remainders. These topics in integer properties lend themselves to an endless number of QC possibilities. In the remainder of this video, we'll just have 3 difficult integer property practice problems for you. Here's the first practice problem. Pause the video and then we'll talk about this. Okay. So f is the prime factorization of 17 factorial. And so quantity a is the exponent of the prime number 5 in that prime factorization, and quantity b is the number of prime factors in f with an exponent of 1. This is a tricky question. So we know 17 factorial is the product of all those numbers. In the positive integers from 1 to 17, there are 3 multiples of 5. There's 5, 10, and 15. Each one contributes 1 factor of 5. So there are 3 factors of 5 in 17 factorial. So quantity A equals 3. There are many multiples of 2 and 3 less than 17. So now we're focused on quantity B. So 2 definitely has an exponent much bigger than 1. 3 has an exponent much bigger than 1. So we're going to ignore those. A moment ago, we saw 5 as an exponent of 3. What about 7? That's the next biggest prime number. Well, 14 is included, and so there's going to be at least 2 factors. There's going to be exactly 2 factors of 7, one from 7 and one from 14. What about 11? The next multiple of 11 is 22, which is larger than 17. It's not included, so 11 has an exponent of 1. Similarly, 13 and 17 have no multiples less than 17, so each of them have an exponent of 1. 3 prime factors have an exponent of 1, so quantity B equals 3. Well, quantity A equals 3, quantity B equals 3. The answer is C. Here's another practice problem. Pause the video and then we'll talk about this. Okay. Well, this is a little complicated comparing these two fractions. We're going to do some simplification first. We need to cancel. So first of all, notice that we could just multiply both quantities by 7 to cancel the 7 in the denominator. That was step 1. So the 21 cancels to 3, the 1400 cancels to 200. Now in each fraction we can cancel vertically. 69 is divisible by 3. 69 divided by 3 is 23. And 5 goes into 240 times. Well, now we can simply cross-multiply. And even cross-multiplying this is perfectly valid in a quantitative comparison, doesn't change the order. And so now we're comparing 23 times 40 to n squared. Well, let's think about this. N squared, we don't know the value of n, but we know it's less than 30. So the absolute biggest that n squared could be would be 900. That would be the maximum value of n squared. It could be anything from 0 to 900. 23 times 40, well, what is that? Well, 23 times 4, we can do that in our heads. 20 times 4 is 80, and 3 times 4 is 12. 80 and 12 is 92. And so that's 92 times 10, or 920. Well, 920 is always bigger than 900, and so it's bigger than n squared. Therefore, quantity A is bigger. This is a hard one. Pause the video, and then we'll talk about this. Okay, when 900 is divided by a positive integer d, the remainder is 1. If n is a number greater than 5,000, when n is divided by 23, the remainder is r. And we just want to compare d and r. And so this looks like a really abstract comparison. You might just think that d has to be the answer because there's no way to do this comparison. But let's think about this step by step. First of all, we know that r is less than 23. That's clear. We're dividing by 23. The remainder is always less than 23. And so that's one concrete fact we know about r. Let's think about that first division. Whatever d is, it must be a factor. If it divides into 900 and has a remainder of 1, it must divide evenly into 900 minus 1. In other words, 899. And so we want to know what are the factors of 899. Well, it might look like that's a number hard to factor. But you may remember from algebra that we had a video on advanced numerical factoring. And if that's one you haven't seen, that's a worthwhile video to go back and look at. That's what we're going to use here. We notice that 900 minus 1 fits a difference of two squares factoring pattern. 900 minus 1 is 30 squared minus 1 squared, which means it's 30 minus 1 times 30 plus 1, which is 29 times 31. And so it turns out that those are the factors, those two prime numbers, those are the factors of 899. So the factors of 899 are 1, of course 1 is a factor of every number, 29, 31, and of course 899 itself. Obviously d can't be 1 because when we divide by 1, there's never a remainder. And so d we know is not 1. So d could be 29, 31, or 899. So we don't know which one d is, but all of them are bigger than 23, which is bigger than r. And so we know for a fact that d is bigger than r. And so quantity A is correct. Remember all the distinctions and exceptions in integer properties. Many integer property questions will demand genuine mathematical thinking. So it's very important to understand these properties very well.